Hello and welcome back to another video. In this problem, we're asked to prove the statement using the precise definition of a limit. The limit as x approaches -6 from the right of the eighth root of 6 plus x is equal to 0. So the precise definition of a limit for a right-hand limit, which is what we have here, states that the limit as x approaches -6, or we'll do the general form here, if we have the limit as x approaches a from the right of f of x equals L. This is true if for every positive number, which we denote by epsilon, there is an associated delta that is also positive, such that if a is less than x is less than a plus delta, then the absolute value of f of x minus L is less than epsilon. So plugging in our values here, a is the value at x is approaching. So if we have -6 is less than x is less than -6 plus delta. F of x is the function, so the eighth root of 6 plus x. L is the value that the limit is equal to, so -0 is less than epsilon. So we have the absolute value of the eighth root of 6 plus x is less than epsilon. What we have here is a even root. So we know that it is taking on only positive values, right? If it's just the standard root, right? The eighth root of x looks like the square root of x, looks like the fourth root of x, and so on. Only takes on positive values. And what's different here is we've added 6 on, which since it's being done inside the function, moves it to the left. So it doesn't move it up or down, so these are all positive values. Therefore, the absolute value of it, since it's always positive, is just itself. And if we add 6 to both sides, or all sides rather, of this inequality, we get 0 is less than 6 plus x is less than delta. Now, if we are looking at this inequality, we can say that if we take it to the 8th power, that the eighth root of something to the 8th is just the thing itself. So 6 plus x is less than epsilon to the 8th. And if 6 plus x is less than epsilon to the 8th, and it's less than delta, then we can say that delta equals epsilon to the 8th. And if we were to plug this back in to the original inequality, which we have to do because the definition of limit states if this, then this. So we have to, using the information that we have, prove that if this is true, this particular relationship, then we get this inequality. So we do that, we have 0 is less than 6 plus x is less than delta is epsilon to the 8th. And taking the 8th root of everything, we get 0 is less than the 8th root of 6 plus x is less than the 8th root of epsilon to the 8th. And we can ignore this 0 on the end here, because if 6 plus x were less than 0, right, then if we were plugging in particular values, we'd be taking the square root of a negative number, and that just, we can't do that. That would be an invalid input. So we can just ignore that because it has to be positive anyways. So therefore we have the eighth root of 6 plus x is less than the eighth root of epsilon to the 8th is just epsilon. Taking the absolute value of both sides, we have the absolute value of the eighth root of 6 plus x, and we might as well just subtract 0 now, is less than the absolute value of epsilon. Epsilon is positive, so it's its own absolute value. And this means that we have f of x minus L is less than epsilon. So from this statement, given the relationship that we found between delta and epsilon, we were able to find that this is true. Therefore, the limit is valid.